I'd like to make the announcement right now, but we're probably still missing people that need to hear that announcement. But here, as we get further into the school year, this class starts at 9:04 because you are to be dismissed from Creative Start at 9:01. So, if your Creative Start teacher is keeping you late, please ask them about that. And if they tell you that you got there late, that's on you. But if you're late coming down here, you're just going to need to come in and catch up because as we get later in the year, I got to start on time because I got a lot to cover. Okay, that's just like I know how much we need to do, and today we need to do over a lesson. Were you not here yesterday? Yes. What groups know that you only have 3? Like yes, this group or I think the middle. I think any of these 3 actually. Laviva, did your group have 4 yesterday, or did you only have 3? You had 4. Okay. We are getting into illness season. Yeah, we're already there. I know it's only mid-September, but we're there. As Riley adds the nice blow of the nose. So please make sure that you are washing your hands often. Please make sure that if you need a Kleenex, you use a Kleenex. Last night I yelled at Dave because as I told you guys, Dave's my buddy who's also a math teacher. But he lives with us right now. And so I'm sitting on the couch over here and he's sitting on the couch right here. And he just all of a sudden goes, yeah! He's like, sneeze. And I'm like, dude, what, like, you didn't even, he just just like shot it across the room. I'm like, bro, Dracula. Like, what? Cover your sneezes, cover your coughs, try to keep it off your hands, right? Try to keep it, like, in or wherever. Or, like, if you're at a desk, sneeze down. Like, sneeze away from people. Try to keep it to yourself. But yeah, try to keep your germs, not our germs. So we need to wrap up yesterday's lesson really fast, and then we're going to dive into another lesson. You don't have a group either. I think you're just right back there. Yeah, we'll just have to have a girls-only group this time. Yeah. Hey, gentlemen, I shouldn't need to tell you to stop drumming right as I'm trying to start the actual class.
My math binder went missing yesterday.
Is your name on it?
Oh, is it red? Go to Miss Collins and she has it.
Yeah, be right now. All right. Tomorrow. I'm out again tomorrow with CPM training. I will be here in the morning, so don't be confused. I will be here for for foundations, doing the MI rotations, and then I will be gone. So you'll probably have a cell. Hopefully, it's unfilled as of right now. So worst case scenario, Mr. Sherg or Mr. Smith or people will figure out who can cover the class. But for you guys, nobody should really have to do much. What's going to happen is probably with the help of Mr. Smith, everyone's going to get their tests back. Everyone is going to get their test back, even if you were done. If you thought you were done, check it. Check all your work. Tell yourself that you've made a mistake and you need to find it. If you weren't done, your first priority is to finish your assessment. Then, check it. Of course, you should always check your assessments before you turn things in, especially if you have fresh eyes. Then, and this is why I have both assignments up there, you have the rest of class period to work on practice work. I know that the practice assignment from yesterday is long. It's like 10 questions. But it's good stuff. So I didn't want to trim that down. I wanted you guys to work through all those. So tomorrow when you're done with the assessment, work on those 2 homework assignments. If you have time left over still and you are done with both of those, 2.2.1 is posted over on that board. It's going to be number 36 to 41. You can work ahead. Is also an option, but I'm not going to have you guys pushing through another lesson just because we don't have class Friday because Outsiders Day. Just with how my schedule went, I just decided you can have tomorrow as a wrap up your test and just kind of catch up on things. Cool? Any questions about that?
No.
Okay. Any questions about tomorrow?
I haven't started my test.
Oh, so they will have extra tests. So if you were absent last Friday, they'll have blank ones. Yeah, Eva. We did. It is the 2.1.1. So it's yesterday's and today. We're finishing 2.1.1 today real quick, and then we're going to move into 2.2.1. And we probably won't get done with 2.2.1 because now we're in this awkward, because we're not starting on 2.2.1. We're going to go back and finish up. So you can have out notes from yesterday if you just want to continue. We were right about here, I believe. Did we wrap up turning 20 33rds into a decimal?
Yeah.
So what did that become? Who can remind me? Actually, I'm going to leave my screens flipped like this. What's today's date, by the way? Because even if you're continuing yesterday's notes, you want today's date on it. 9/18, right? And you don't have to have the year if you don't want. We know what year we're in. It won't matter then. Sky, what did 20/33 become, and how did we know that?
We turned it into 60/99. So then, since we knew that 99, we did what was on the top, and we just turned it into decimal. So 0.66 and so on.
So anything over any amount of nines has that nice, easy rule. So challenge for you to see if you remember this from yesterday. If then I give you, and I don't think I gave you guys this one yesterday.
No, you did.
Did I? Oh, dang it.
You gave us like a
Hold on.
After we finished it, though.
We did.
Well, hold on. Let's just make sure that we remember exactly what we... All right, turn that into a decimal. Check with your group. So be careful. Be very careful. Talk with your group. There's one thing you got to do before you can jump to the repeating decimal. You guys have enough light back here. I know we get a little bit of light when we get a curtain, but I might need to get another one from back here.
Oh, yeah, I knew that.
All right, using cards this morning. Nathan, what do I need to do before I can turn this into my repeating decimal? Do you remember what our rule was for how many digits we repeat? We add a 0 on here because how many digits does this need to repeat? 4, right? So we put a 0 right here, and it's going to repeat 0, 1, 2, 3, and all of that gets the repetend. Do we remember that rule? Are we good enough on that for now to move on? All right, now I'm about to blow your brain. Again, yes. So we now have some really cool relationships, like beautiful relationships, that I'm going to start to show you a couple of them, but then we'll come back to this because I don't think we have enough time today. So on your paper, please write down 1/7 or 1/7. This is actually, 2-6. Yeah, this is 2-6. This is number 6 if you're numbering your notes. 1/7. Well, and then I extended beyond that problem, so we kind of went rogue for a minute. 1/7. If I try to make it 10, not good. 100, still not good. 1,000, still not really good. 10,000, yeah, still hard. So sometimes we just use rules and little tricks or things like that. So we could use a calculator. We could type that in there. But this has a really cool relationship. What's 7 times 2?
14.
What's 7 times 4? Did I already show you guys the sevens? And then what comes after this?
Oh, wait, I have
Careful.
57.
57. And all of that repeats. So remember, the sevenths repeat, but then they had that cool little trick. So did we look at the 2 7ths and 3 7ths and 4 7ths? So if you want to remember that, go back in your notes. But this is where CPM reminds you of, like, okay, so sevenths, other values also have these repeating tricks. And then we can, and I don't think we're going to today just for the sake of time, we can look at other interesting denominators such as like 15 or 13. Like 13 is kind of a gross denominator. But 15, what's nice about a denominator of 15 is it can be reduced sometimes. Right? So if we have a value such as 3/15, what can we reduce 3/15 down to, Ethan? 1/5. And 1/5 actually does not repeat. So we have different denominators that sometimes always repeat, like the sevenths, every single seventh repeats. But 15ths, depending on if you can reduce it or not, it will not always repeat. Any questions on that or anything you encountered in the homework last night before we move on to the next one?
Okay, so this is kind of weird, but since I wasn't here yesterday, how are you doing that?
The reducing or the 7?
The 7.
I just know that. That I just had in memory. You guys don't need to, but I couldn't remember if we've talked about this previously. So in other classes earlier, we talked about these always use the 7s, always use the same digits, always in the same order, but 2 7s would start here.
Yeah.
3 7s starts there. 4 it's just that little trick.
Okay.
But just relating that all the 7s repeat. Like we know that. We talked about that. Other denominators such as like 15, some of them repeat, some of them don't. Right?
Why do you skip 3 from 7?
It's just how it happened. Like it's just a really cool relationship. There's not like we could go through the long division and look at why that happens, but we don't really need to. It's just a cool kind of beautiful relationship that we see there. Aiden?
I just have like a nice little like something that might help you.
Yeah.
If you wonder sometimes, like I used to wonder why like it was 0.2. If you think about it, because of 2, 4, 6, 8 times would equal 5. So that's why I marked down. So 2, like
Yeah. Just to illustrate what Aiden's trying to say. We can, oh, and actually, that's a perfect segue into what we're doing today, so thank you very much, Aiden. We know how to read and write numbers based off exactly what they're called appropriately, right? So not the names where we say, like, point whatever. But when we have certain, sorry, so guys, we're going to shift into 2.1.2 now, so if you want to go ahead and switch your header. Now we're doing decimals to fractions. So now if you want to turn it around and put dec and then the arrow to decimal to fractions now.
Oh, they made fractions.
We are going to look at that right now. So we had the question of how do I turn a repeating decimal into a fraction? Well, we have to know those certain rules and certain tricks. So look at 218. Now, these webs, or the representation portion web, whatever they call it, portion web, you don't really need to make all the arrows and stuff they do. What did I tell you just need to make? Triangle, right? So make your triangle. My ink layer is broken today, apparently. So make your triangle, put 7/10 at the top.
Can we just make a regular triangle?
Yeah, yes, that's exactly what I was just saying. You don't have to make the whole weird curvy web thing. We're just going to make a triangle. Now, 7/10 is easy, right? It's not repeating. It's a fraction that we know, and it's named very nicely. And we're not going to worry about the inside of the triangles right now, because obviously we're saying it's 7/10, and that's what we would write inside. But then as a decimal, when we come over here, we know, well, okay, the first decimal place is the what place? The tenths place. So it being 7/10, the 7 goes there, and we're done. Now, what a percent means is per what? Out of 100, right? Per 100. This number is actually over 1, right? Any number we can put over 1. So if we want to turn this into a percent, we have to turn the denominator into 100. So we have to multiply by 100 in the top, and we get 70, which is how we get this percent value.
It's very easy.
The other trick people like to... I have a lot of like murmuring. Jalen?
My first grade teacher, she showed us a trick. To get to 100, you just add 0 on the bottom, and then whenever you do the bottom, you do the top, and that on 7/10.
Yeah, so if we started with 7/10 and wanted to turn this into 100, since I put a 0 on the bottom, I also put a 0 on the top. The other thing people will sometimes tell you to do to make your life quote-unquote easy, there's zeros out here, right? We talked about this yesterday. There are infinitely many zeros. You can also just move. Now, we're not just moving. We're actually doing the math. but we can quote unquote move the decimal 2 places, and that turns us into a percent. Right? So my decimal needs to land there. My decimal's actually right there now. So do this with the other 3 there, B, C, and D. So we got 0.75, we got 3/5, and we got 5/8. The 5/8 is weird, and I kind of goofed this up on homework last week, actually. So check with your team. We're making these triangle webs for all 3 of these. You do not need to reduce the fractions right now. So if you just want to put the fraction exactly how it starts on top, that is fine. You can read it as exactly how it is. How do we properly read the number 0.75? Because that's not proper. How do we properly say it? Joey?
Good morning, Harold Hacker.
We can actually, we don't need to say the 0.
Thank you.
Eva? 75 hundredths. Right? That's how we properly read that. So that's how we write it. 75 hundredths. That already tells us what our percent is. Because we know if we have a denominator of 100, our percent is just the numerator, and we get 75%. Any questions on that one? All right, keep going. If you haven't done C yet, do C. It is 3/5. It gives you the verbal.
That one would be easier because all you have to do is change it into like tens.
Okay, Ava, how do I do that? What does this become?
You have to multiply by 2, so it would be 6 over 10.
Be 6 over 10.
And then you just add 2 zeros
We'll add 1 0. Be careful.
to both.
Yeah, sorry. So 1 on top and 1 on bottom. Yeah, I'm with you now.
And then, so the percent would be 60%.
Awesome.
And then wouldn't that be 0.06?
Be careful. It's just 6/10. It's not in the hundredths place.
Oh, so it'd be 0.6.
Yeah.
Okay.
Make sure that what you have agrees with this. Ava walked us through. She said, well, that's easy because the 5 can become a 10, and then the 10 can become 100, and then we have our percent. And when I go back and I look at the 6/10, it tells me what the decimal is. Any questions here? These are all terminating, right? So they're all a little bit easier.
They're terminating.
5/8.
They're all getting the chopper.
I'm trying to think of some other lines from those movies, but I'm at a loss. 5/8. Now, I had to help a decent amount of people with their homework on the 8ths. So if you have not done that problem yet, you really want to pay attention, or if you didn't do it correctly, you really want to pay attention. 8 does not easily become 10. But 100, kind of. We're going to involve a decimal there. But 1,000, and I was pushing somebody to do this on their homework, and they were like, but why do we want to get so big? And I said, because it's easier. Like, even though it's bigger, it's easier. So remember, if we don't know how to multiply to get there, what do? Divide it backwards. So 1,000 divided by 8, and I could grab a calculator and do it, but that is 125. The multiplication there. Which, as we talked about yesterday, we want to avoid using decimals in fractions. That's not appropriate. So if we multiply up here by 125, well, 5 times 100 is 500. 5 times 25 is another 125. We get 625. Now, hold on. So to go decimal, 625 thousandths, I can write that. 625 thousandths.
Is there always just going to be a 0
Unless we're over 1, unless we have an improper fraction. Because these are proper fractions, we know that there's going to be a 0 in front. Now, do you want to say what you were just saying? How How did you get there? And can you speak up for the class?
62.5%.
But how? Do you know, like from up here? Laviva? Guys, if you're not writing, I should have your eyes up here. So we could move this decimal 2 places and get to the 62.5. Or up here, if I turn my denominator into 100, I got to divide by 10 to do that. So this becomes 62.5. Now that's not appropriate, but it's okay. I'm not using that as my answer. I'm using that as a working number to get where I need to be, which is percent. So we would not, if you were trying to like give an equivalent fraction, you would not use this, right? That's not appropriate. But we're trying to make percent. It's good. Any questions on any of those?
No.
Casey? Question? What you're talking about on topic?
No.
I appreciate your honesty.
Are you supposed to write something in the middle?
You would either draw a picture, write a verbal, but we've been saying it out loud. It's like 5/8 would be like the verbal, or you could write 5 out of 8 or 5 divided by 8 or like any of those verbals. But for the sake of time, we're just kind of trying to move fast. So, dragging this back down for our friends who might be sick at home. So we're going to practice that again. Do not reduce these. Okay, do not reduce these. I want you and your group to rewrite A through F in fraction form, not reduced. Now then, if you get done with all those, then you can go back and reduce if you want to. But at first, do not reduce. Just write those exactly how they should look in fraction form based off their name. This is problem 19. Sorry, to be this zoomed in, I can't really, it's like too far up here. Thanks. I don't know why you think that. You haven't even gotten your first test back.
Have you seen my last math teacher?
But I have not. I don't know who it was. But let's avoid going there. I don't like talking bad about other teachers. Smart ink. Why you know word? Wait, did you just hear what I said?
No, we're talking about my teacher's name was Miss Schlegel, and Layla was like, it sounds like a sneeze.
I think everything sounds like
Schlegel.
Okay. So, can you guys get on topic, please? Otherwise, I'm going to have to restructure
Math
groups.
is great. Math is 2 plus 2 equals 4.
Ava, doing those problems that I just asked you to do.
2 plus 2.
All right, to make sure we're all centered in the right place. Madison, how do I appropriately read this number? 19 hundredths. So we write it 19 hundredths. That's it. And because 19 is prime, we know we can't reduce. Do that for all of those. Be careful down here. Be careful with those. Keep going.
Okay, guys, so the next one is 0
People eating trash all over.
No, I did freeze tech yesterday.
Sure you did.
No, because you got my
Oh, I even missed that yesterday. Yeah, with
Yeah, I
eating
told her about
decimals.
it.
You can always go back and watch the video. It's posted.
I watched Dynamic Down.
But it was in a math style, so she was like talking in math, like language.
So the language that app is typed in called latex. It's capital L, lowercase a, capital T, X. Like, not like latex, but like it has its own. Yes. So if you're curious, you can look that up.
Okay.
I was just talking fine. 011001. Riley, how do I write B? Because your card was up. 391 over 1,000 because it is 391 thousandths. Now, Natalie, the dangerous one here, what about C? Sorry, I said you missed that. Sorry you missed that. Hey, I have a lot of like just random noises. Remember, 7th grade appropriate classroom behavior. Thank you. 1 over 1,000 because that 1 is in the thousandths place. Now D is even more dangerous. Sure. Keep me from drawing all the cards. 19. Now, hold on. But only the 9 is in the thousandths place.
But there's a 1.
Oh, wait. Is it 9,100?
She's right. But I'm just pushing us to remember the name of the number. And therefore, the denominator is determined by the last decimal place value. If you would like to, so I made this offer the afternoon class, but I should say it for this class. If you would like to teach my class, here's the pen. No joke. Shh. Hold on. However, what that really means is you have to prepare, you have to plan, and you have to have all of the notes done. Come show me that you know what you're doing, and then I'm not joking, you can teach my class. However, one, all of you that keep interrupting me when I'm talking, you just wait until I'm the student and see how fun that is. If you want to do that, then you would not have to do, well, it depends on what the lesson is, but you would likely not have to do that practice work. You would be up here teaching, but you have to do like the whole lesson, and I then am a student who doesn't know what's going on, and I ask a lot of questions. So, for real, if you want to teach my class, you can. But be careful, because now that we've had this conversation, I reserve the right to remind you of that, and if what you are doing seems like you feel as if you are more important than what we're doing together, I reserve the right to hand you the pen and say, okay, teach. And if you can't, obviously you shouldn't be off topic. Because if you can't hop up here and teach your peers what we're doing, then you shouldn't be talking over the teacher who's trying to help you. Right? So, no joke. Now, obviously this offer's not good for today because you have to prepare, you have to plan it ahead of time. But I'm not joking. I've had it happen before and work very well. And the kids are like, oh yeah, I might actually, I liked that. That was fun. I might want to teach. I've had it happen before and kids, give up 5 or 10 minutes into it because they can't handle trying to control their classmates. So, that's that. 19 thousandths because the final location tells us the decimal, which then if we want to jump to F, same amount of decimal places, right? 3 decimal places tells me the denominator there is also going to be 1,000. E class, what's E? 3/10 or 31/100 or 300,000. I mean, you can keep going, right? There's a lot of equivalent fractions. All right, questions. Questions. I know your hand was halfway up in for a second. Okay, so now try 20, where we're going the other way around. So hold on, I'm going to scroll in a second. So, sorry, we're really going to skip on down to 23. 21. The 73 got in my head and goofed me up. So remember, 0.73 repeating. If this was what was given to you, this is where kids start to forget that the rule works both ways. So go ahead and on your paper write down 0.73 repeating, with the rep attendant.
Wait, are you not doing the screenshot?
I am, but it's not on the right page. I just need to slide it up because I keep switching back and forth. I wish I could actually throw this up there from there, but there you go. Now, Jerome starts writing this, and he's like, well, I know that the number that repeats goes on top, and I know that this decimal ends right here, so I'm going to name it 73/100ths. But Jerome's friend walks up and said, dude, that decimal doesn't end there. That decimal doesn't end anywhere. This doodad the repetend means that it never ends. So he tells Jerome, this is wrong, dude. Right? The bottom is not 100 because my decimal doesn't actually end anywhere. So what, Sky, do we do instead?
Oh, well, I would just like it would be 99.
Yeah, why?
Because you know that 99.
Why is it 99 instead of 9 or 999? How do we know there's 2 9s on bottom?
Oh, because there's 2 digits on the top.
Because we know that there are 2 digits on top, and however many digits repeats, or however much repeats over here, tells me how many 9s I have on bottom. So, remembering that, try to convert the decimals in 21 into fraction form. Right there. Yep, with your group.
Wait, we just learned that that's 7.
Sorry, I think I said the statement the other way around. Because then we will continue on to down here to converting more of the, but sorry, convert the fractions into the appropriate repeating decimals. Sorry, too much planning in my head. Just take those, turn them into decimals. It depends on what the homework is, but if you show me that you already like mastered the skills in that lesson, I wouldn't have you like practice those problems again. But CPM's homework kind of pulls a lot of different stuff in. It doesn't just practice what you get that day. So you would at least have less.
I understand that. That's so good. Okay, A. 19 over 99. 19 over 99 is not multiple of D.
So it would be really helpful if you write the fraction as well. Because if we start with the fraction, we actually know what's going on. So like these, you don't have the decimals that we have. Showing there to like remind you what we did and why like this was 391 over 1,000 versus that being 3 over 10. Like, you don't have that number. Which also that 100 wasn't true.
Okay,
And
guys.
we found out that Jerome was wrong. So the thing that we're missing here that you aren't doing is we care about the numerator of the fraction. So anyways, because you're actually making all of this look identical to each other, like all the 0.9. We're not focusing on the denominator, we're focusing on the numerator. So the denominator tells us how many numbers what those numbers are. So write down the fraction 19 over 99. Hey guys, reminder, do not just write the decimal, write the fraction first, and then write what the decimal is. So 19 over 99, I have 2 9s on bottom, which means I'm going to repeat 2 numbers, which means this decimal is 0.19, and that's what repeats. So it would be 191919. But if you don't want to write all of those, we can just write 19 with the repetend over top of it. Does that make a bit more sense? So what then would be and then put the bar on top of it, because you got to show that that repeats, so that bar is the repetend. It tells us that decimal keeps repeating.
39.
Hold on, you mix that up a little bit. It's
Oh,
399.
done, yeah.
And especially where you're sitting, you can turn your desk if you need. So what's going to repeat? Not 0 to a number. We only have 3 9s on bottom. So we know 3 numbers. We don't. Yeah.
Wait, what did C be?
And then we put the bar up. So keep doing that for the rest of it, right? If there's 1 9 on bottom, we repeat 1 number.
Well done.
Yeah.
Look, I'm done.
Sure. I mean, you're missing. You use the ellipse.
No, I was
underneath the 9 you're going to use the ellipse. You have to show what happened before you use the ellipse. So you would only write 391, 391, 0.291.
Yeah.
So, really good point to bring up here. You put the zeros in the wrong place.
Sorry.
So remember, if we have to add zeros, do the zeros go to the left or the right of the numerator? The left of the numerator. There we go. Now put your repetent.
Oh, right.
So go fix that on your paper if you need. Easy thing.
No, I had it.
Go double check. So in B, walking around, Sky wants to use the ellipse. Right? Now she should not just do that. Because my question to her then was, okay, so does the 1 repeat? Does the 9-1 repeat? Or does the 3-9-1 repeat? If you want to use the ellipse, you have to show what's happening first. So you need to show the repetition, and then you could just put ... Which is why, when you're writing, the repetent is better. Like, I don't like telling you what's better because I like you to make your own choice, but this is, like, the repetent is more appropriate if you're writing. If you're if you're typing on a computer, you're like trying to help somebody, you're texting them, whatever, if you're typing, then there's no repetent, right? You can't type that. Then we use the ellipse. But if we're writing, you should be using the repetent. Class, what's C? You should already have it done. 0.3 repeating.
0.5.
And check this.
0.19.
Give me your attention real quick. All right, I got 5 minutes left, so please do not start packing up. I see some people like really wanting to. They're like just waiting, like their pencil's already gone, and it's like, so chill. I got 5 minutes. Hey, this is when you really got to be honest, because this is where stuff starts to like ramp up. We're gonna have a quiz or a test, something on this next week. So right now, if you were given any of those fractions or any amount of 9s on bottom, because you know me, I might just give you a problem with like 8 9s on bottom, and you got to figure out what repeats. Does anybody have questions? Because like once we understand the rule, it should be easy. I'm not telling you this starts easy, but once we get it, it should be easy. Ava?
Okay, I just want to make sure that I understand it because I had to have.
Yeah, and you weren't here yesterday.
So, can you just like make a fraction?
So, like I just said, let's say I decide to go crazy, as if I'm not already there.
Oh my god. Oh my.
And you don't have to write this down, but Ava asked for another one. So let's say I give you 8 9s on bottom. And then on top, it doesn't matter what I give you, 7, 5, 8, 4, 6. Who cares? But if there aren't 8 digits up here, I have to make it have 8 digits because I know I want to repeat 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. And what repeats is 0, 0, 0, 7, 5, 8, 4, 6. All of that. It makes sense? Any other questions? Check that out. Ava was bold. She asked the question, and now she's like elated because she gets it. Ava.
So one question I have is for on the test.
Hey, I should not see people getting their big binders out. I should not hear clipping. I still have 4 minutes left, and Aiden's talking. Respect your classmates.
Anyway, so will the triangles be on our test? Like
Yeah, showing, well, not necessarily make the triangle, but converting fractions, decimals, percents. You should be able to start with any of those, fraction, decimal, or percent, and go to any of them.
Okay.
So if I say take this percent, make it a fraction. Well, that's easy. Just put it over 100. If I say take this decimal, make it a percent. You should be able to do that. Move the decimal point or whatever. If I say take this fraction, make it a, you should be able to do that. Okay, by next, there's no test this week. No quiz, no test or anything this week. We have Outsiders Day on Friday.
Yay!
All right.
On Friday, guys.
No, I mean, you could not come to school if you want, but you're going to miss a whole lot of awesomeness.
We don't have to come to school.
You never, well, okay, you have to come to school.
Oh, it's like,
All right, now, check this. Hey, so, pencils down. Just give me your attention. I want to explain to you why this actually happens. And if it doesn't make sense to you, you're right there with me. I never understood this till I got to college. I'm not joking. So, and that's not to scare you, but that's to tell you, like, it just didn't quite click in my head, and it didn't need to, because I, like, learned another way around it. But I don't like teaching you guys, like, tricks and just saying, well, it just works. I need you to know why. So let's say we have a number, some number, x, that we don't know what the fraction is, right? This is going to be some fraction. And we know that's equal to a decimal number, let's say 0.19 repeated. So what we actually want to do, and this is shown to you in the book if you want to watch their version of it, but I just wanted to give you a different one. What we actually want to do is be able to deal with this with some numbers on the left of the decimal. Right now I don't have any numbers on the left of the decimal. So what we can do, according to our algebra rules, and this is what we've been doing with our fractions, if I do it on the top, I do it on the bottom. Same thing here, if I do it on the left, I do it on the right. So I multiply both of these by 100, which turns my x into 100x, and it turns this, well, times 100 moves things 2 places, into 19.19 repeated. Any issues with what I've done so far? Any questions? I got 2 minutes. We're going to make this happen.
okay.
Then I want to get rid of the 0.19 repeating. Well, I know what the 0.19 repeating is. It's x, right? It was what we started with. So if I want to get rid of that, all I really need to do is subtract x away. But over here, I don't have x's, I have numbers, so I subtract 0.19 repeating. Now, although I can't reach the end of this, I know they're both the exact same thing, right? This 0.19 repeating on the end here, and this 0.19, those are the same value. So when I do this, I get 99x equals 19. To get x by itself, and it's okay if all of this doesn't make sense right now, I just wanted to show you guys, we can divide by 99. A number divided by itself gives you 1, so I get 1x. The value of x is 19 over 99. That's how we algebraically prove why that fraction is that decimal. Have a great day.